Hello, and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence. Today, we are exploring a massive shift happening right now across the industry. We are moving past the era of flashy, experimental AI demos and entering the phase of operational maturity. It is no longer just about building an AI agent. It is about making that agent reliable, governed, cost-effective, and safe for real-world production. Let's begin.
Yeah, it truly is a structural shift in how we approach all this technology. I mean, we spent the last few years in what you might call a honeymoon phase.
Oh, for sure. Just getting an AI to write a coherent email felt like actual magic.
Right, or summarizing a massive document in 10 seconds. But if you are listening to this and you're actually tasked with running a business, you know pretty quickly that magic doesn't scale.
It definitely doesn't pass a corporate compliance audit, that's for sure.
Exactly. And what we are seeing across the board right now is that the enterprise infrastructure is finally catching up to that initial ambition.
Because before an AI agent can actually do anything meaningful for your business, you need hard proof that it works. And, proof that it isn't going to quietly drain your entire cloud budget overnight.
Right. There's a totally different standard.
I always think about it like how you handle hiring. You wouldn't hire a brilliant but, say, highly erratic employee, completely skip their onboarding, and immediately hand them the phone to talk to your biggest client.
No, of course not. You'd lose the client.
Right. You put them on a probation period first. You test how they handle stress.
Which is actually the exact philosophy driving Google's Gemini enterprise agent platform, which just became generally available. They've realized that enterprise buyers, well, they just do not care about a polished, tightly controlled 5-minute demo on a conference stage anymore.
Yeah, anyone can make a demo look good.
Exactly. They want offline experiments. They want automated drift alerts. With this platform, Google is essentially mandating that an agent be evaluated against over 20 pre-built metrics before it's ever considered production ready.
Okay, let me stop you right there because 20 metrics sounds, kind of like overkill.
You think so?
Well, I use consumer AI models every day. If it answers my question accurately, I just move on. Why does a business need a massive dashboard of 24 dials just to verify that an agent is doing its job?
Because the failure modes in a business environment are entirely different. Like as an individual user, you can instantly spot a bad answer and just hit regenerate, right?
Yeah, true.
But if you deploy an autonomous agent to handle, say, thousands of customer service tickets, you aren't reading every single response. You can't.
Right. It's acting on your behalf without supervision.
Exactly. So those 20 metrics measure things like safety, tool use accuracy, and grounding. And grounding is crucial here.
Break that down for us. What does grounding mean in this context?
It evaluates whether the agent is actually pulling its answer strictly from the provided facts, or if it's subtly hallucinating plausible-sounding fiction. You have to simulate hundreds of user environments and store those custom metrics in a registry for your whole organization to monitor.
So it establishes a mandatory testing baseline.
Yes, precisely.
Okay, I can see the need for a baseline, but getting the correct answer is really only half the battle, isn't it? Because there is a pretty brutal economic reality to running these systems at scale.
Oh, absolutely.
I was looking at how AWS is handling this with their Bedrock AgentCore Observability suite. And it turns out an agent might give you the absolute perfect answer, but if it takes too long to generate or burns too much compute power doing it, it's entirely useless from a commercial standpoint.
That is the hidden trap of enterprise deployment right now.
Mm-hmm.
You can build an agent that is technically flawless in its reasoning, but if it operates without strict latency budgets or cost controls, it will just obliterate your gross margins.
Yeah, which defeats the whole purpose of automation.
Exactly. So AWS is leaning heavily into what they call trace-level diagnostics.
What does a trace-level diagnostic actually look like in practice? Because, isn't that just a standard error log?
Not at all. With traditional software, it either works or it crashes and throws a very specific error code. But AI agents rarely crash in that traditional sense.
Right. They don't just put up a blue screen of death.
No, instead they degrade. So a trace-level diagnostic actually maps out the exact microsecond and the exact subroutine where an agent got stuck.
Oh, wow.
Yeah, it lets you see, for example, that the agent spent 40 seconds repeatedly querying your database simply because it didn't understand the format of the data it retrieved. It gives you this kind of X-ray vision into the AI's reasoning loop.
That brings up something I really want to push you on because it ties directly into how these agents degrade. There's this concept I've been seeing of uncontrolled memory growth.
Right, the context
Yeah,
processing.
how does an AI agent basically lose its train of thought over a long session? If I sit in a 3-hour strategy meeting, I might get mentally fatigued, but my brain doesn't just, stop functioning. What is fundamentally happening under the hood there?
Well, it requires looking at how the architecture actually processes information.
Mhm.
Think of an AI's context window, like a strict, highly rigid short-term memory limit.
Okay.
In a long, ongoing session with a user, the agent is constantly taking every new question, every retrieved document, and every single previous answer it gave, and appending it into its working memory.
It just keeps stacking it up.
Yes, and it reads that entire massive transcript from top to bottom every single time it needs to predict the next word.
Wait, seriously, so it's essentially rereading a massive novel every time I ask it a simple follow-up question.
Yes, and if you do not actively manage or prune that memory, the transcript just grows and grows. The mathematical attention mechanism, the thing that calculates the relationship between all those words, scales quadratically.
Meaning the math gets exponentially harder.
Exactly.
Yeah.
That means eventually the agent is processing so much historical text that it becomes incredibly slow and vastly more expensive to run. It basically gets buried under the weight of its own history.
That's fascinating.
And ironically, because the prompt is so bloated, it often loses track of the immediate instruction you just gave it.
That sounds like an absolute nightmare, not just for your cloud bill, but for the customer waiting on the other end of the screen.
It really is.
So if you are an engineering manager, what are the actual dials you need to be watching to prevent that?
So the industry is rapidly converging on 4 vital key performance indicators that need to be on every single agent's dashboard. First is the task success rate. Did the agent actually resolve the user's core problem?
Makes sense.
Second is the P95 completion time.
Right, okay, let's break down P95 for anyone listening who isn't living in data science dashboards all day.
Sure. P95 stands for the 95th percentile. If you are building a tool for your customers, you do not care about the average response time because averages hide the extremes.
Right.
You need to know how long your slowest 5% of requests take.
Yeah.
If your average time is 1 second, but your P95 time is 45 seconds, well, you have a massive chunk of users who are having a terrible, frustrating experience.
Got it. You have to solve for the worst case scenarios. What are the final 2 KPIs?
Third is the cost per successful task. And fourth is exactly what we just broke down, context and memory growth per session. You need an alert the moment an agent starts hoarding too much memory.
Okay, so we have established our baseline. We have an agent that is economically viable, it's fast, and it doesn't bankrupt the company.
Sure.
But all of that efficiency doesn't really matter if the agent doesn't actually understand the specific business it works for.
Context is everything.
Yeah.
And we are no longer just talking about generic contextual awareness. We're talking about strictly governed business semantics.
Which is fascinating because I want to push back on how companies were being told to handle this even, say, 6 months ago.
Oh, the advice has changed completely.
Right, because for a long time, the prevailing wisdom was traditional RO, retrieval augmented generation. The advice was just, take all of your company's PDFs, all your HR manuals, all your financial reports, throw them into a vector database, and the AI will just magically figure it out. Why isn't that enough anymore?
Because vector databases operate on semantic similarity, not on strict business logic. And relying purely on similarity can actually be incredibly dangerous for an enterprise.
How so?
Well, a traditional system retrieves information based on the words used, but it does not inherently understand your organization's unique, rigid definitions.
Give me a concrete scenario where vector similarity completely derails a business process.
Okay, imagine you have an agent deployed for your executive team, and the CEO asks it to calculate quarterly revenue. To an AI, the words revenue, gross revenue, and net revenue are semantically very similar.
Right, they'd all be clustered together in the database.
Exactly. They're grouped closely together. If the AI doesn't know the rigid difference between your specific company's definition of those terms, the final number it spits out is totally useless. Or consider the term active customer.
Oh, right, because every company measures that differently.
Exactly. Does your marketing department define an active customer as someone who opened an email in the last 30 days or someone who made a purchase in the last 90 days?
It's a huge difference.
Huge. If the AI simply pulls a random document that says active customers are up 10%, but it's using the 30-day definition when the CEO needed the 90-day definition. The agent just confidently presented false information.
And if you are making strategic financial decisions based on that dashboard, you are flying blind.
Completely blind.
This is the exact problem AWS is targeting with their new Agentic catalog workflow in Amazon Quick. They are shifting away from basic document retrieval and moving toward using existing metadata, strict glossary definitions, and corporate governance rules.
Yes.
The agent essentially inherits the company's specific dictionary before it ever tries to answer a question.
It bridges the gap between unstructured AI creativity and highly structured business data. But, there is a second layer to this context problem.
Which is?
Once the agent understands your vocabulary, how do you give it its operating instructions without causing that memory bloat we discussed earlier?
Ah, yes. This is where Google's agent skills in GenKit Go comes into play, which, by the way, supports TypeScript, Go, Dart, and Python. They're completely moving away from the old method of cramming every single rule, procedure, boundary, and edge case into one massive system prompt.
Right. The mega prompt is dead.
Instead, they're utilizing an architecture called progressive disclosure. Explain the mechanics of that.
Progressive disclosure is a brilliant way to optimize an agent's brain. Instead of loading a 10,000-word instruction manual into the prompt every single time a user says hello, you package those instructions into small, discoverable modules.
Like little specific skill sets.
Exactly. The agent is aware these modules exist, but it only loads the specific instructions for a skill at the exact millisecond the task requires it.
It reminds me of backpacking. Forcing an AI to hold all of those contingency plans in its active memory is like forcing a day hiker to carry a heavy winter tent, an avalanche beacon, and snowshoes in their backpack just to walk 2 sunny miles in a local park.
That's a great way to look at it.
It slows them down, they get exhausted, and it just makes no sense. But these new dynamically loading agent skills, they are like having that heavy survival gear magically teleported into the backpack only the exact second a blizzard hits.
That is the perfect way to visualize it. Loading every single procedure into every single request drastically increases your token usage, which, costs money. But worse, it distracts the model.
How does it distract it?
The model's attention gets split across rules that aren't even relevant to the current question. By using modular skills through progressive disclosure, you keep the agent's context incredibly lightweight. It stays fast, it stays cheap, and the model remains hyper-focused on the immediate task in front of it.
Okay, so internally, we have built a powerhouse. We have an agent that is economically monitored. It understands that net revenue means net revenue, and it travels light, only pulling the tools it needs. But we still have to put grown-up rules around the system. We have to govern who is actually allowed to talk to it, and more importantly, we have to prepare for what happens when the underlying brain of the agent suddenly changes.
This is where we cross the line from cool AI projects to true enterprise infrastructure. You simply cannot give everyone in a massive corporation the exact same level of access to these models.
But wait, if I'm a business owner and I am paying a premium for an enterprise AI platform, why wouldn't I want my entire staff from top to bottom having access to the absolute smartest, most capable model available?
Because different departments have radically different risk profiles. This is exactly why GitHub has introduced their new team-level model policy targeting for Copilot business and enterprise.
Oh, walk me through that.
Well, a software developer who is experimenting with new code architecture in a sandbox environment needs access to a highly permissive, experimental, and creative model. But what about your legal team?
Ah, right. Legal is handling confidential contracts and sensitive client data.
And your finance team is handling proprietary earnings data. If they're querying a highly permissive model, there is a serious risk of data leakage. Or the model might generate non-compliant legal clauses.
That would be a disaster.
Absolutely. They need strict risk controls, entirely different data class permissions, and tighter spending limits. GitHub's new policy allows an enterprise administrator to set a global safety baseline and then individually assign specific models to specific teams based on their roles.
Role-based access control has been the standard in traditional software for decades. It makes sense that it's finally arriving for generative AI.
Exactly. It's just good governance.
Which makes sense, but here's the piece of operational reality that genuinely caught me off guard. You can build this incredible, governed, efficient workflow, properly assigning roles to legal and dev, and then the provider can just pull the plug on the model you built it all on. The models themselves aren't permanent.
Model retirement is rapidly becoming one of the largest operational risks for a modern business. It is no longer just a minor inconvenience where a developer has to update an API key.
Yeah, GitHub just recently completed the deprecation of Gemini 2.5 Pro and Gemini 3 Flash, and they forced all of those users over to 3.1 Pro and 3.5 Flash.
Ready or not.
To me, relying on a cloud model feels like waking up in the morning, putting on your suit, getting ready for work, and finding out the manufacturer broke into your garage overnight and completely swapped the engine in your car.
That's exactly what it feels like.
Sure, it might be a newer, faster engine, but you have absolutely no idea if your old keys still work or if the transmission is even connected anymore.
And if you have built a complex, automated workflow that relies on the exact behavioral quirks, the specific formatting, or the precise reasoning steps of that old engine, there's a very high probability your car is not going to start.
Right.
When providers change their default models, or alter their pricing tiers, or retire a model entirely, your dependent workflows will break. A newer model might suddenly decide to output JSON data in a slightly different structure, and your entire downstream database pipeline just crashes.
So how do you actually prepare for that? Because you can't just cross your fingers, switch the toggle to the new model, and hope it plays nice with your legal department's tools.
You have to treat all AI models as temporary, highly volatile infrastructure. Companies now need to maintain a strict model inventory.
Like a backup plan.
Yes, you need a pre-approved list of fallback models ready to deploy instantly. You need a migration runbook. But most importantly, you need automated regression tests.
What does a regression test look like for an AI? Since it's generative, it doesn't give the exact same answer twice anyway.
It's non-deterministic. So you build a suite of thousands of prompt and response pairs that represent your core business functions. When you are forced to swap to a new model, you instantly run those thousands of tests through the new system.
I see.
You use another AI to evaluate if the new model still calculates that net revenue equation correctly, if it still follows your strict brand tone, and if its JSON outputs still match your parsers.
You essentially have to verify the keys still work before you try to merge onto the highway.
Precisely. Model resilience and modularity have to be baked into your system architecture from day one. You cannot be permanently tethered to a single version of a single model.
Which provides the perfect bridge to our final reality check. Because up until now, we've been talking about internal safety, protecting our data, managing our costs, surviving a model swap.
Right.
But as these mature, governed AI systems start generating voice and video that actually face the outside world, your actual customers' businesses face the ultimate test of maintaining trust and absolute brand consistency.
And this is where we are seeing a massive industry-wide push for verifiable provenance. We can look at OpenAI recently adding synthetic watermarking to their GPT Live audio, which applies to content generated through ChatGPT voice and their developer API.
Now, when I hear the word watermarking in the context of AI, my brain immediately goes to politics. I think of it as a tool to stop deepfakes or prevent misinformation on social media. But you are saying this is actually becoming a boring, mandatory corporate compliance issue.
It is becoming a strict procurement requirement. If your company is going to deploy synthetic voice for automated customer service agents or use it to generate automated media and podcasts, you need a deterministic mechanism to identify your own generated audio.
How does Synthi actually do that?
It works by modifying the audio waveform at a spectral level. It embeds a signal that is totally inaudible to the human ear, but it's instantly recognizable to a scanner.
Why does a brand need to scan its own audio?
Because if a piece of controversial or legally problematic audio leaks online and it sounds exactly like your branded customer service voice, your legal team needs to be able to instantly scan it and say, no, this does not contain our cryptographic watermark. It did not originate from our approved systems.
Wow, okay. That is a huge liability shield.
Exactly. It allows you to manage public disclosure, investigate internal misuse, and definitively protect your brand. Provenance is just a mandatory checkbox for modern content governance now.
It is the digital equivalent of a corporate wax seal. And that level of absolute control isn't just about defensive security. It is also about proactive consistency, especially when we look at video generation.
Oh, definitely.
Look at what XAI is doing with their Grok. Imagine video 1.5 update. They have added native 1080p text-to-video capabilities, But the actual headline there isn't the resolution, it's the reference control generation.
The ability to provide persistent character references, persistent scene environments, and persistent voice continuity.
Which is massive for anyone who has ever tried to make AI video. Before this level of control, generating AI video was literally like shooting a commercial where your lead actor is recast in every single frame.
Oh, it's so frustrating.
Right, you would type in a prompt for a man in a red jacket walking down the street. In shot 1, he looks like a young Brad Pitt. In shot 2, he suddenly looks like Danny DeVito, and the jacket is inexplicably blue.
Yeah, the temporal consistency was zero.
It was a fun parlor trick, but it was completely unusable for a serious brand. How does this new reference control fundamentally change the economics of content creation?
It completely flips the economic model. Because as you pointed out, the real business value of Grok Imagine 1.5 isn't just that the video looks better or more realistic.
Yeah.
It is the ability to create a repeatable, deterministic, branded content system.
So it's about predictability.
Yes. If you are an agency running a multi-million-dollar brand campaign, or you are creating a series of episodic training videos, you need the protagonist to look exactly the same across 20 different scenes. You need the brand's specific hex colors to remain perfectly preserved in the background of every shot.
And you need to be able to achieve that without spending thousands of dollars on compute power, manually regenerating the exact same clip for 5 hours, just praying the AI finally gets the jacket color right.
Exactly. Reference control drastically reduces the manual editing time and drives down the cost per usable clip. You are moving away from a generative slot machine where you pull the lever and hope the AI gives you a matching character.
Right, no more slot machines.
You are moving toward a deterministic rendering engine where you can actually plan, storyboard, and execute a consistent marketing campaign.
It really is the professionalization of the entire creative stack, mirroring exactly what we discussed with the operational stack. From running trace diagnostics to evaluate the economics of the agents, to grounding them in strict corporate semantics, governing which departments get to use them, and finally, ensuring that the media they produce is consistent, branded, and cryptographically verifiable.
It really ties it all together.
It is a completely different landscape than it was even a year ago.
It is a phenomenal maturation of the technology. We have officially moved from the era of exploration into the era of execution. The systems are incredibly capable. The true challenge now is oversight and management.
I couldn't agree more.
And, if we connect all of these pieces to the bigger picture, it raises a fascinating and perhaps slightly unsettling question for the near future.
Let's hear it.
If you consider that we are building all these incredibly intricate dashboards to evaluate agents, to monitor their memory growth, to verify their semantic accuracy, and to run automated regression tests every time a model retires, how long is it going to be until we have autonomous AI agents whose sole, dedicated job is to manage, evaluate, and potentially even fire other AI agents?
That's all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe, and join us next time for the latest in AI. Until then, keep building what outlives you.